Okay, so now let's try to talk about the Euclidean algorithm for finding the greatest common divisor. So we are talking about the Euclidean algorithm, and the idea of the Euclidean algorithm is to find the greatest common divisor of two numbers. Namely, what number is the greatest divisor of both? Okay, so for example, if we have, I don't know, 12 and 6, so GCD of 12 and 6 is, for example, 6, because this divides 6 and this divides 12. But if we are talking about, for example, 9 and 6, so we are getting 3 because it can divide both and it's the biggest that divides both. Okay, so this is the greatest common divisor. So the Euclidean algorithm tries to give a method to find the greatest common divisor. Of course, it's easy for small numbers like I did, but it gets harder when doing greatest common divisor. For example, this one and that one. Try to find it. Good luck. So, or maybe this is a good example. How can we find this solution for this? Which number can divide both big numbers but without any remainder? So the idea is that there is an algorithm, and it's called the Euclidean algorithm for finding the greatest common divisor. So we are starting with two numbers, a and b, two integers, a greater or equal to b. So now we start to divide and divide and divide, and we replace each time the value of a and b and r. So every time we divide a to be b times q plus r, and then while r is the remainder and q is the quotient, and then we repeat, dividing until we get to r equals 0, and then return the last r before it became 0. Okay, let's see an example. It will be the best. Let's try to take the greatest common divisor of 48 and 18, which should be 6. Let's try to find it. So we are taking a to be the greater number, the bigger number, which is 48, and b to be the smaller number, which is 18. And now we start to divide until we get to no remainder at all and return the remainder before it became 0. So the first time we say that 48 equals some, remember, this is a equals b times q plus r. So 48 equals 18 times something plus remainder. So divide 48 by 18, you get 3 is 30 plus 24, no, so 2 is 36, so uh, 3 is too much, it's 54, it's more than 48, so we need to take 2, and the remainder it's 18 times 2, which is 36, and we have a remainder of 12. So here R is 12, B is 18, and A is 48. Now we continue, we switch. Let's say each time switch. We switch between A gets B and B gets R. And we continue. We repeat until we get. So we do the switch. A equals B equals 18, b equals r equals 12, and we repeat. 18 equals 12 times something plus r. Now, of course, 12 can be one time inside of 18, so it's 18 times 1 plus remainder is 6. So again, we have a equals 18, b equals 12, and r equals 6. Now we're doing the switch. So a equals b equals 12, b equals r equals 6, and that's it. Now again, we continue because the remainder r is not 0. So 12 equals, which is a, equals b is r, is 6 times q plus r. Now we can say that q should be 2 and r gets 0. So we got to a place where r is 0. So we finished. What is the solution? The solution is the last r before it became solution 6, because this is the r before it becomes 0, before it became 0. So the remainder, no, the greatest common divisor of 48 and 18, right? We started with 40 and 18, is the last r before it became 0, which is this one. So this is 6. Okay, so you saw how we used the Euclidean algorithm, this repeating, using the formula, using this idea, dividing again and again until we get to a time we divide without any remainder, and we get the greatest common divisor between two numbers. This is the Euclidean algorithm. This is the idea. Thank you very much. If there are any mistakes or correction, please tell me. Divide until r is 0. And every time, switch between a and b and r, like we did. Thank you very much. This is about the Euclidean algorithm to find the greatest common divisor, and that's it.